So this is section 4.3 for this unit. This unit is actually quite small. And our goal today is I will identify characteristics of partial variations. Now, if you recall, our note from before dealt with what we call direct variations. And remember, direct variations were in the form y equals either mx or kx, depending on who you were talking to. And one of the things we knew about this is that the graph of a direct variation went through the origin 0, 0. Okay, so that's why it was direct. Now, partial is going to be a little bit different. So first of all, partial has an equation in the form y equals mx plus b. I think I've seen that before, and hopefully you have too. Okay, so first of all, we know b is our y-intercept. Now, for these types of questions, it's what we call our fixed or initial value. Because one of the things you should have known about the questions that you were doing yesterday, they were word questions. Okay, and it's the same kind of thing here. These are word questions looking at relationships. So it's the fixed or initial value. Okay, now the m is actually the same as what it was before. It's the slope or the constant of variation. So what's different here is that we have, this is the same, but this time we have an actual b value, whereas for the direct we didn't have a b value. The b value was 0. So when we look at these, and I'm just going to move this down, first of all, the graph does not go through the point 0, 0. So all it means then for that, it just means that the graph is going to go something like this, or it might go something like this if it has a negative slope or a negative constant of variation number. So it doesn't go through 0, 0. The table of values is different as well. Notice that's kind of highlighted. In the table of values, when x equals 0, the y will not, and I repeat, will not equal 0. Okay, so that's how I can tell that it's a partial variation. Okay, so it just means that if I have a graph, I can tell whether it's direct or partial. If I have any table of values, what will happen is I'll have 0, 1, but for the 0, I might have a 4, then I might have a 2. So what's happening is I'm having different numbers other than 0 for my y value when x equals 0. So that is where the huge difference is from a table of values. Okay, so let's look at an example. It won't take very long tonight, actually. So we have our example. You can see it's a table of values that for some reason I didn't finish. And this is why it says complete the table of values given that y varies partially with x. Okay, so partially. So they're related to each other, but it's only partially. And then what it says, identify the initial value of y and the constant of variation and use this to write an equation. All right, so how am I first of all going to figure out what numbers are missing? Well, first of all, the first thing that I would do is I would examine to see whether, first of all, my x's are going up in an even amount. Okay, so it looks like they're going up by 1, so that's a good thing. Makes it a little bit easier for us. If I look at the y values from 6 to 9, what's going on there? Well, it looks like because I know it's varying partially, I know that there will be a constant here, and the constant, notice, is 3. So it means that it's going up by 3, so it would make sense then that this next number would be the 9 plus 3, which would be 12. And then if I added 3 to 12, oh, I do get 15, so we're doing it right. So if I add 3 to 15, I should also get then 18. Okay, so that makes sense. Uh-oh, this time I have to complete the x value. So how am I going to do this? Well, a couple different ways. I could keep adding threes to see what happens. Okay, so the next one would be at 5. It would be, if x was 5, then I would have 3 to added to 18 would be 21. If it was 6, then it would be 24. If it was 7, it would be 27. Oh, there it is. So it's 7 as our answer here. Okay, now can you imagine, however, if I put a real large number here? Okay, if that would make it much harder. You would have to keep doing this, and this takes time. Okay, it's not as efficient. Could we figure it out? Sure, we could. So the other way that we can do it is by actually finding the equation, and you have the ability to do that. So it says identify the initial value of y. Well, what is the initial value of y? Well, the initial value of y is when x equals 0. So there it is there. So our initial value for part B is our B value, which is our y-intercept, equals 6. And our slope, or our k, depending on, again, who you're talking to, our slope is 3 over 1, which is 3. So our equation, pretty easy, right? Because if we use the form y equals mx plus b, or kx plus b, we end up having y equals 3x plus 6. Oops, plus 6. So it's amazing how much stuff that you can do now with a table of values that doesn't have all the information in it. You can figure it out. It's amazing that you actually can come up with equations. Okay, so you're doing an awful lot more than you could do when you walked in September. Okay, so this type of question, we would also have word questions. And although I don't have a word question here, actually I'm going to add one. And sorry about that because it's not on your sheet, which means you're just going to have to add it. Okay, so I just typed that for you, and it is Mrs. B gives everyone 12, oh, sorry, should be 12 candies. Okay, so I'm going to give you 12 candies, everyone. And then each day you come to school, she'll give you 3 more. Okay, so what would the equation of this be? Well, if we look back at this, and I'm going to just go up, I know you need to copy that down yet, but we have our slope, or the constant of variation, and we have a fixed or initial value is our B. So here our initial value is, guess what? Mrs. B is going to give you 12 candies. So that is my B. That's my initial value. Okay, so that's the initial value to the situation. And that's fine, but where is the slope coming from? Where's that constant of variation? Well, the constant of variation is how many am I giving you each day? So actually, your constant is 3. Every day you're going to get 3 more candies. Now, I need to define what my variables are. So let's have, let's C be the number of candies, the total number of candies. Oh, that B. Let's see. And when we're doing this, let's just make this thinner, makes it much nicer. Let C be the total number of candies. And then what we have to do is we have to now talk about days, because obviously every day you're going to get 3 more. And then, so we would let C that. And so how about we do D for days? That makes sense. Let D be the number of days? So it would make sense then that the total number of candies would equal, first of all, the 12 candies I'm giving you, and then 3 times every day. Okay, so if you notice I wrote it that way, and it doesn't matter whether you write it that way or you do total number of candies equals 3 times D plus 12. They mean the same thing. Sometimes when I'm translating, because they often tell us that initial value first, sometimes it's easier to put that in first for the equation. It just makes it easier for translating sometimes, but either way works. So again, if you notice, it's in the form y equals mx plus b. Okay, in the sense that we have a b value other than 0 this time. Okay, so some questions tomorrow in class.